Hello, class. I chose the Dead Sea for my project. It's between Israel and Jordan in the Middle East. I've been there multiple times, and I just love the land, very arid and dry. Some key facts about the Dead Sea: world's saltiest large body of water. It has a salinity of approximately 34.2%, one of the saltiest large bodies of water globally, roughly 9 to 10 times saltier than the ocean. Extremely dense water creates effortless floating. So it has a high salt content that increases water density, making it easy to float in. The lowest point on Earth's surface, the surface of the Dead Sea is roughly 1,410 feet below the sea level, the lowest exposed land elevation on Earth. The Dead Sea Transform, or the DST, in plate tectonics, located along the boundary between the Arabian Plate and the Sinai subplate, functions as a left lateral sinistral transform fault system, accommodates lateral displacement of 4 to 5 millimeters per year, responsible for the formation of the Dead Sea Divergent or Pull Apart Basin and Jordan Rift Valley. It's linked to the recurring seismic activity and earthquake hazards in the region, and we'll get to that in another slide. Tectonics have influenced landforms, settlement patterns, and the regional economy. So here's the Dead Sea, and that's where it would be in relation geographically. Cultural, historical, and economic impacts of DST. Mineral-rich deposits, salt, potash, bitumen, shaped ancient trade and industry. Historically used in mummification, medicine, and commerce. Modern importance for tourism, health resorts, and mineral extraction. Seismic risk from the Dead Sea transform affects infrastructure and urban planning. And regional history of earthquakes, destruction, e.g. ancient cities, 1995 Aqaba quake. So rocks and minerals of the Dead Sea. This is an actual photo of salt cave walls in the region. This is actually Mount Sodom. It's a diasphere. Very interesting. That cause evaporate minerals, halite, gypsum, potash, bromine, magnesium, that form by extreme evaporation. Tectonic activity along the Jordan Rift created the basin and lifted up salt diapirs like Mount Sodom. Valuable mineral extraction fuels modern industries in Israel and Jordan. Historical uses: bitumen for Egyptian mummification, salt for preservation and trade. And minerals continue to shape the region's economy, culture, and heritage. Geologic time in Earth's history, formed along the Dead Sea Transform Fault, African-Arabian plate boundary about 20 to 25 million years ago. Regions shaped by tectonic extension and subsidence, creating a deep rift valley, lowest place on Earth. Sedimentary layers include the Lycine Formation, late Pleistocene, which about 15,000 to 70,000 years ago, showing climate and lake level changes. Fossils are rare due to hypersaline water, but the surrounding basin preserves archaeological and paleo-environmental records. Geologic history drives today's economy, potash, bromine, magnesium industries, and supports tourism and cultural identity. And here's the Dead Sea Transform Fault circled there. Earthquake and landslide hazards. Historical quakes, as you see the dates there, cause widespread destruction, landslides, and liquefaction. 1927 Jericho earthquake, which measured 6.3, caused severe damage across Jerusalem, Jericho, and Amman. Sinkholes are increasing due to falling water levels and the dissolution of salt layers, posing a threat to both infrastructure and tourism. Risk reduction encompasses seismic hazard mapping, resilient building codes, and international early warning systems. And despite mitigation efforts, the combination of tectonics, shoreline retreat, and fragile landscapes continue to pose a high hazard. Here's a sort of like a graph here. Hazard inputs, independent variables, observed impacts, dependent variables, moderating, mediating factors. And you can see all those there. Outcome was high seismic and anthropogenic stress, increased probability of destructive events, and substantial mitigation and planning equals reduced vulnerability and economic loss. So this slide shows the relationship between the EM31 conductivity and sediment thickness into two stretches of the Dead Sea. The EM31 is a geophysical instrument that measures the conductivity of the ground. Higher values often indicate more saline and moisture-rich sediments. Stretch A on the left has conductivity values ranging from approximately 15 to 30 and exhibits sediment thickness between 150 and 400 centimeters. So this strong correlation suggests that conductivity is a reliable predictor of sediment thickness in this area. Stretch D on the right spans on 35 to 60 MSM conductivity range, with sediment thickness ranging from about 80 to 300 centimeters. The weaker correlation indicates that while conductivity still relates to thickness, other local factors such as lithology, hydrology, or dispositional environment also influence the results. So Dead Sea water, the climate is very, very arid. The average rainfall is only 2 to 3 inches. Most falls in short, intense storms that cause flash floods. Terminal lake system, hypersaline, endorheic lake reliant on Jordan River inflow and episodic flood pulses. High evaporation. Evaporation dominates the water balance measured at extreme rates. Declining levels. The diversion of inflows lead to rapid drop in lake levels, destabilizing groundwater and forming sinkholes. And industrial evaporation ponds and mineral extraction, potash, bromine, and it remains central to the region's economy. And here's an actual industry working at the shores of the Dead Sea. Climate and environmental changes, hyper-arid desert climate, annual rainfalls low, summer temperatures often exceed 104 degrees. Climate change, the human water causes. Annual drop in lake level results in higher evaporation, salt dissolution, and shoreline subsidence. Natural resources, obviously we need them, but we need to govern them, the extraction of them better. Very rich in a lot of minerals there at the Dead Sea area. And then human and ecological impacts. Industrial extraction, they combine the formation of thousands of sinkholes and coastal erosion, resulting in increased instability. Regional economics rely on mineral exports and health tourism. And the ancient salt trade and biblical significance shape the cultural heritage. The ongoing decline underscores the urgent need for sustainable resource management. And that's the Dead Sea. Shalom and thank you. And thank you, Professor, for the class and teaching us. Congratulations, everyone. Here are my references.